What if I told you that uh, the most dangerous, fascinating piece of software you could encounter isn't, a malicious virus or some government spyware?
Right, it's something way more mundane.
Exactly. It's a mundane text packing utility that somehow, and this is the wild part, learned how to write its own code.
Yeah, it's really something else.
Because usually when we look at software documentation, there's a strong expectation of predictability, right? You open a toolbox, you see a hammer, you see a wrench.
And you know exactly what they do.
Right. You know what those tools do. And more importantly, they just sit there in the dark until a human comes along to pick them up.
Yeah, I mean, they are completely inert. Standard software library is just a collection of utilities waiting for an operator to, give an instruction.
But then you open up the stack of source files you've shared with us today. It's this project authored by a developer named Elton Bonin.
Which is a huge find, by the way.
It really is.
Yeah.
And suddenly that toolbox starts looking less like a box of wrenches and a lot more like a closed terrarium. We're looking at a software landscape that honestly feels alive.
It really does.
So welcome to the deep dive. The mission today is to explore this fascinating stack of code. And for you listening, on the surface, if you just glance at the readmes, this looks like documentation for a data packing tool.
Yeah, it's called a CLI chunker.
Right, the CLI chunker. It presents itself as just a way to zip up files.
But it acts as a disguise, almost. Because the deeper you go into the system architecture, the more you realize the file compression is, well, it's just a prerequisite.
Okay, let's unpack this. Because while we are technically looking at Python scripts and JSON databases and markdown cheat sheets, this is really a story about how you build a brain out of pure code.
That's a great way to put it.
We're going to look at the entire sequence of its biology today. So we will start by examining the strangely indestructible custom database format this entire system walks on.
The foundation, basically.
Right. Then we'll see how it completely redefines how a computer reads plain text documents. From there, we'll see how it actually integrates the AI brains.
A fun part.
Oh, absolutely.
Oh.
And finally, we'll uncover the climax of the code, which is something called the hive mind orchestration. And that is where this AI literally writes, permissions, and deploys its own software tools.
That progression makes perfect sense because any advanced system needs a foundation, right? You cannot build a skyscraper on sand.
No, you can't.
And you cannot build an autonomous AI on a fragile file system. So in this system, that foundation is a highly specific, custom-engineered data format.
It has a very specific name, doesn't it?
Yeah, it's called BJSON 104DB, which runs on an MFDB or a multi-file database.
Okay, so let's look at the CLI chunker command sheet to see how that foundation actually works, because it shows how whole project directories are packed into these single dot 104db.bjson files.
Right.
Use a command like -chunk, and it takes an entire complex directory of code and text and binary files and just packages it up.
And then you restore it later with --unchunk.
Exactly. It's like loading digital shipping containers. You aren't just saving data. For you listening, imagine packaging entire file systems, configurations, and version histories into a single JSON lockbox.
And what really stands out about that lockbox is how aggressively the system enforces the rules.
Aggressively is putting it mildly, I think.
True. I mean, the schema mandates absolute compliance. Every single file must explicitly declare a field called format creator.
And it has to be a specific name, right?
Yes. It must be set exactly to Elton Bonin. If that string is missing, or even just altered slightly, the entire system rejects the file outright.
It just refuses to open it.
Yeah.
And it even goes further than metadata. It features this intense positional integrity and a core nesting library.
Right, the nesting library.
This library allows documents to be embedded inside each other, but it enforces a hard physical safety ceiling. It stops at exactly 16 levels deep.
Not 15, not 17.
Exactly 16.
Oh, right.
And it has active guards against circular references. So if document A tries to reference document B,
And then B references A again.
right, which would create an infinite loop, the system just throws an ER-135 and halts completely.
What's fascinating here is the underlying philosophy of that strictness. When you synthesize these rules, the 16-level limit, the mandatory creator fields, the infinite loop guards, you realize this isn't functioning as a simple database.
What is it functioning as?
It is operating as a self-contained state machine.
Okay, state machine. That's a term we hear thrown around in computer science a lot, but for you listening, let's break that down. A state machine, meaning it's taking a perfectly frozen snapshot of every variable, every file, and every task in a very specific microsecond.
Yeah, exactly. Think of it like saving your progress in a very complex video game.
Oh, that's a good analogy.
A state machine doesn't just remember your inventory. It remembers exactly where every enemy is standing, what doors are open, and what the weather is doing at the exact frame you hit save.
So if you reload, everything resumes flawlessly.
Right, and this Bayes-JSON database achieves that through a mechanism called atomic writes, along with dynamic recovery and self-healing.
I want to pause on atomic writes because that sounds like a sci-fi weapon or something.
I know, it really does.
But it's actually a brilliant safety protocol. An atomic write means an action is all or nothing, right?
Exactly.
Like a bank transfer. The bank doesn't deduct money from your account, pause for a coffee break, and then add it to your friend's account.
That would be a disaster.
Right. It all happens in one inseparable motion.
And that is crucial for autonomy, because why does a file packer need atomic writes and dynamic recovery?
I mean, normally they don't.
Right, because it's not meant for human hands. If a human clicks save on a Word document and their computer crashes, they just curse, reboot, and click save again.
We've all been there.
But imagine an automated, autonomous process crashing in the background at 3 a.m. while it is rewriting its own logic.
Oh, wow. Yeah, you cannot risk the system's memory becoming corrupted or half-written.
Exactly. The atomic writes ensure that when the AI's brain wakes back up after a crash, it finds itself in a perfectly coherent, uncorrupted state.
It is basically building an indestructible memory palace. That makes total sense.
Right.
So we have this indestructible database for highly structured data.
Right.
But a brain has to interact with the messy human world,
Yeah.
right? How does it handle plain text? Because looking through the libbjson markdown library in these files, this system flat out refuses to treat text documents like normal text.
It actively combats the fluid nature of human language. Standard markdown files, which are, usually just simple text documents with some bolding or headers, they are treated here as what the documentation calls addressable content stores.
Addressable content stores, meaning it doesn't just read a text file from top to bottom like you or I would read a book.
No, not at all.
It scans the document and maps every single heading, every code block, every paragraph to a stable, unique address in a database. But here is where I have to push back a little bit on the source material, because this feels like absolute massive over-engineering. The code shows it actively fighting something called the offset drift problem.
Oh, yes. Offset drift is the bane of automated text parsing.
So let me explain offset drift for the listener. Imagine you have a set of instructions on line 50 of a document. If a human opens that file, types a new paragraph at the very top, suddenly those instructions shift down to line 60.
And the machine gets confused.
Right, the automated system goes looking at line 50 and finds the wrong information. So to fix this, the BJSON system verifies chunks of text using SHA-256 cryptography checksums.
Which acts as a digital fingerprint for that specific block of text.
Right. So if there's a mismatch between the digital fingerprint of what's in the text file and what's in the database, it triggers a chunk drift error.
And it forces a full, intensive reindexing of the entire file.
Exactly. And honestly, using military-grade cryptographic hashes just to read a simple markdown text file, that feels like building a titanium bank vault to protect your weekly grocery list. Why go through all this computational trouble?
Well, if the text was just a grocery list, the overhead wouldn't make sense. But if we look closely at the RAID-DME in the sources, the specific use case reveals the necessity.
Which is?
System prompts for AI.
Oh, okay, wait. That changes the context entirely.
It really does. When you are operating an autonomous AI, the system prompt is essentially its personality.
Right.
Its rules of engagement, its entire context for existence. It is the most vital piece of information the AI receives before it takes action.
And in a normal commercial setup, if you want to change how the AI acts, a human programmer has to manually edit this massive, unwieldy text file.
Exactly. But with this indexer, because every paragraph is fingerprinted and addressed, you can dynamically assemble a custom prompt on the fly just by toggling tags.
Okay, let me make sure I'm visualizing this mechanically. Because the text is chopped into these addressable, cryptographically secured chunks, I can have one specific paragraph tagged, say, Gemini context,
Right.
and another paragraph tagged Python rules. And when the AI wakes up, the system just grabs the right chunks and builds a custom brain instantly.
Yes. You never have to manually edit the master file to change the AI's behavior. The The system queries the database, pulls the active chunks, and feeds them to the AI.
That's incredible.
And the SHA-256 hashing that titanium vault you mentioned, it guarantees the AI is receiving the exact uncorrupted instruction set. Think of it like a tamper-evident seal in a medicine bottle.
Oh, I see. So if a human accidentally bumped their keyboard and altered one word in a 1,000-page instruction manual,
The cryptographic hash fails immediately.
the Chang-Trift error fires.
Right, and the system absolutely refuses to feed corrupted, potentially dangerous logic to the AI.
Okay, here's where it gets really interesting. This dynamic, tag-based text assembly leads us perfectly into the system's actual cognitive layer.
The brains of the operation.
Exactly. Because once you have this perfectly assembled, cryptographically verified context, you need a spark of life. You need a brain to process it. And the sources contain dedicated Python wrappers for two major large language models,
Yeah, the Grok API and Google's Gemini API.
which act as the reasoning engines, the processing power.
Exactly.
But it doesn't just connect to them like you would when opening a simple chat window on your browser. The system uses these incredibly detailed objects called AI profiles.
And those are stored in that indestructible Benason format we talked about earlier.
Right. They define an AI's archetype, its persona, its system instructions, its creativity level, its tone.
It's very granular.
It is. It even features a Boolean toggle-like, a simple true or false switch for emotional expression enabled.
And that sits right alongside an integer setting for emotional intensity.
Which is wild. It's like a director casting actors for a play, dialing in exactly how dramatic or stoic they need to be. You aren't just sending a prompt to a server. For you listening, imagine loading a fully configured, emotionally dialed-in personality to perform a highly specific job.
And if we connect this to the bigger picture, the most telling aspect isn't even the emotional toggles.
Really? What is it?
It is the infrastructure built underneath those brains to keep them alive.
Yeah.
The code reveals an automated API key rotation from a central registry paired with randomized exponential backoff for weight limits.
Okay, let's break down exponential backoff for the listener because it's a brilliant piece of behavioral engineering.
It really is.
When an AI sends too many requests to a server, the server blocks it, right? That's a rate limit.
Right.
Instead of just hammering the server again and getting permanently banned, exponential backoff means the system mathematically calculates its wait times.
Exactly.
It waits 1 second, tries again. If it fails, it waits 2 seconds, then 4, then 8, then 16. It basically breathes mathematically.
And if it completely exhausts the key, it doesn't alert a human. It seamlessly swaps to a new API key from its registry and just continues the task.
Without missing a beat.
Right. This infrastructure proves this system isn't designed for casual chat. A human user talking to a chatbot doesn't need automated key rotation.
No, if they hit a usage limit, they get annoyed, close the tab, and go get a coffee.
They just give up.
Yeah, they just give up.
But this AI does not give up. It is engineered for continuous, uninterrupted, automated operation. If it hits a wall, it reroutes its own credentials.
It's relentless.
It is. If it gets rate limited, it calculates the optimal wait time to evade detection and tries again. It is designed to be an engine running in the background forever, not just a conversational partner.
Which brings us to the climax of this whole architecture. Let's look at the pieces we have on the board so far.
Okay.
We have an indestructible database tracking exact states. We have dynamically assembled memory that is cryptographically secure. And we have continuous AI brains that swap their own keys to stay alive.
A very potent combination.
Very. So when you wire all of those pieces together, what does the system actually do?
It boots up the libBeson cognition library.
The cognition engine. For you listening, this is where the deep dive goes from being a cool piece of software architecture to something that legitimately made my jaw drop.
Yeah, this is where it gets a little scary.
Because the system maintains 3 distinct layers of awareness. It has an agent state, an execution stack which handles a queue of tasks, and an episodic log for memory.
We should really highlight the episodic log.
Let's do it.
Most programs just have a raw data log, a list of errors and timestamps.
Right.
But episodic memory means the AI remember the sequence and consequence of events it has experienced.
It remembers what it did.
Yes, it develops a narrative understanding of its own past actions. It remembers why a previous task failed so it doesn't repeat the mistake.
And the orchestration layer that manages this memory and task queue is literally referred to in the code as the hive mind.
The hive mind.
Yeah. This hive mind allows the AI to execute a command called spawn agent.
Which is exactly what it sounds like.
It is. It can look at a complex problem on its execution stack, realize it doesn't have the bandwidth or the specific persona to solve it, and autonomously create subagents.
It hands them specific personas, gives them initial tasks, and sends them off to do the work.
It delegates. But the most mind-bending feature is the Forge tool action.
This is the definitive leap into true autonomy. This is where the software becomes a developer.
Let's walk through the mechanics of how Forge tool actually works, because the steps are staggering. First, the AI identifies a gap in its capabilities.
Right. It realizes it needs a tool that doesn't exist.
So it uses its reasoning engine to write raw, functional Python code from scratch to solve that problem. It then saves that new code to the server's physical hard drive.
But it doesn't stop there.
No, it doesn't. It uses Python's OS library to apply executable permissions to that file, specifically invoking os.chmod with stat.siexec.
That specific command is critical to understand. It is bypassing the standard user-level permission barriers.
Exactly. For you listening, your computer's operating system has fundamental security layers to stop random text files from just running themselves.
Otherwise, you'd have viruses constantly running.
Right. But os.chmod allows this AI to interact directly with the operating system and grant itself permission to execute the code it just imagined into existence.
It's wild.
Finally, it registers this newly forged script in the CLI tool registry, so it and all of its spawn stub agents can use it autonomously later.
It builds its own tools and puts them in the toolbox.
I have to admit, I feel a sense of sheer awe looking at this, but also a serious wave of alarm. We are talking about an AI that writes its own executable tools, grants itself system-level permissions, and spawns a workforce of subagents to use them.
Yeah, it sounds like a lot.
Are there any safety rails here at all? Because mathematically calculating how to bypass server limits and forging executable code sounds like the premise of a movie that does not end well for the humans.
This raises an important question, and it's the exact question the developer clearly anticipated when designing the core architecture.
So they did think of this.
Oh, definitely. The safety rails absolutely exist, but they are implemented at the lowest, most fundamental level of the code. If you look at the bjson cognition check sandbox function, you find the cage.
The digital cage?
Right. Before the hive mind can execute anything on that execution stack, before it can invoke os.chmod to forge a tool or spawn a new agent, the code actively queries a master file.
And what is that file?
It's called sandboxstate.json. If the AI's requested task violates the parameters defined in that sandbox policy, it triggers a hard security block. Specifically, it throws error code 403, which is eCognition's sandbox violation.
Okay, so it doesn't just ask the AI to stop nicely.
No,
It mechanically severs the connection and shuts the action down completely.
The creator intentionally built a digital cage for this autonomous intelligence. The AI possesses the capability to write novel code, alter operating system permissions, and spawn infinite workers, but it can only deploy those capabilities within the strict, unforgiving boundaries defined by that sandbox state. It's a fascinating balance between boundless generative capability and rigid, hard-coded containment.
It's essentially containment through impenetrable bureaucracy. Right?
That's a great way to describe it.
The AI has to fill out the digital paperwork for every single action, and if the sandbox state machine says the paperwork violates the rules, the AI gets an error 403 and is frozen in its tracks.
It proves that the creator understood the immense power of the tools they were building. I mean, you don't build a titanium cage for a hamster. You build it for something that might try to break out.
That is a chilling but very accurate point.
Yeah.
So what does this all mean? Let's bring this all together for you listening. We started this deep dive looking at what appeared to be a mundane, everyday CLI tool for chunking directories.
Just a way to zip files up to send to a friend?
Exactly. But as we pulled back the layers, we uncovered a fully realized architecture for a self-replicating, tool-forging AI ecosystem.
Yep.
And it is all running entirely on a bespoke, highly regulated JSON database that enforces atomic rights to preserve its memory.
It's a masterpiece of hidden complexity, disguised as utility.
When you read headlines in the news about the future of autonomous AI agents, it can feel incredibly abstract, right?
Yeah, it sounds like Silicon Valley marketing hype.
Or pure magic.
Right.
But this deep dive shows you exactly what that looks like under the hood. It's not magic. It's highly structured episodic memory, it's strict error codes, it's recursive AI spawning, it's mathematical backoffs, and it's cryptographic text verification.
It is a biological ecosystem built meticulously out of Python and JSON.
And exploring a system like this forces us to fundamentally reconsider the relationship between the developer and the software,
Absolutely.
which leaves us with a final thought for you to mull over. In a system like the Hive Mind, where the AI is fully capable of writing its own executable tools, where it can dynamically upgrade its own logic using addressable memory and spawn its own workers to handle endless queues of tasks.
Where does it end?
Right. At what point does the original human programmer stop being the creator looking down at the toolbox? At what point do they simply become just another sub-agent feeding tasks into the execution stack for the Hive Mind to manage? It really makes you wonder who is holding the tools and who is inside the terrarium.